So hello guys, welcome back. Determine, I've already skipped the drawing part. So let us read. Determine the cross-sectional area of members AG, BC, and CE for the truss shown in figure P-112. The stresses are not to exceed 20 kSI in tension and 14 kSI in compression. A reduced stress in compression is specified to reduce the danger of buckling. So, the missing are AG, BC, and CE. There are nodes. First, we need to make sure that our supports are right. So the reaction for our roller is the reaction perpendicular to its orientation. And for a pin support, we have two, the vertical and the horizontal. So taking a moment at C, at A I mean, that should be A, wait. We will cancel the forces AX and AY. Let's write the dimensions. So we have dx, so 6 plus 6 plus 6 is 18. And the forces, it rotates clockwise, 25. So negative 25 multiplied to, that should be 8. 4 plus 4. So a force is on the vertical multiplied to 4 equals 0. So let's check input. So alpha x multiplied to 18 minus 25 times 8 minus 40, alpha equals 0. Answer is 20, and it should be in kips. So dx is 20 kips. Next, we can summate forces at x equals 0, right is positive. So negative dx, let's write 20, and ax equals 0. Ax equals 20 kips. So summation of forces y equals 0. Going up is positive. So 1, 2, 3. We have only 3 forces. Negative 25, 40, plus ay equals 0. Ay equals 65 kips. Now we've got our reactions, support reactions. So let us try cutting a segment here between members CD and DE. Let us name it AA. Small letter A, small letter A. We can also cut a segment. So we can, looking at AA, the segment AA, we can only calculate the DE. So we need to cut another one. We are trying to solve this by method of sections. So segment BB. So I will skip the drawing part. So this is C. If we take a moment at C, we will cancel the forces CD and CE. That means we can bring out EF. So 20 to the moment arm of 6, that is the vertical. Now since our EF is assumed to be in tension, its force components should also be in tension. So going down, and with the moment arm, it should be negative. It is clockwise, so 2 over square root 13 multiplied to EF equals 0. So member EF is equals to, okay, we missed the moment arm. EF is equals to reciprocal multiplied to 6 all over 4. Our value should be 36.06. Keeps. Yep. Next is, it is intention. Now that we have EF, what we are trying to do is to solve for CE. That means we need to, by method of joints, we need to expose the joints that are for affecting E, joint E. So I will skip the drawing part again. So here's sum of forces X equals 0. Going right is positive, dx is going left negative. So the component is also. Now if we try to cut a section, a vertical section at joint D, we would know that CD is on the negative side. So negative, the slope multiplied to the member CD, we would have negative 36.06. Negative only means that our force is on the different direction. It is in compression in this case, since we assume it was tension. Some force is Y going up equals positive, so negative DE is negative. This slope, if we cut a horizontal section through D, we would know that DE is negative, which is on the lower side. So substituting, we would have DE is equals to, which is in tension because it is going away from the segment, from the joint D. So at joint E, we can now calculate CE. Just skip the force and the drawing again. So sum of forces X equals 0. Going right should be positive. Let's assume that right is positive. So negative CE, because it goes left. We don't need the DE actually. So this is the slope. Multiplied to 36.06 equals 0. Bringing out, we would have a negative. Let's try to input it. Try to check. Take note that we have a negative. So it should be on the other direction. So we can round it up to 20, only 20. It should be in compression because we assume tension. So in our problem, we have a limiter, we have a restriction of 14 kips per inch squared, or KSI, for forces, for members that are in compression. So that was 14, which is squared kips. We'd have 20 over 14, which is 1.43 inches in squared. Next, we can solve for AG. Joint A. So let's skip again. So we have sum of forces Y equals 0. Going up is positive. We have 65, which is the AY. So So plus, because if we cut through section A, a horizontal line, we would know that AB is positive. So the reciprocal, and it is negative. So negative. Which is negative 78.12, which is in negative, so it is the other direction. AB is in compression. Next, we need to solve for AG now. We can solve for AG. Sum of forces x equals 0. Going right is positive. So cut our horizontal line to know direction, but it is AG plus 20 and plus the component is slope. So we would have 23.33. So I had a typo error, and this is tension. So the limiter when tension is over area AG. .33 over, that should be in caves. We have the restriction, which is 20 KSI. A of AG is equals to 1.6167 inches squared. Now we've got to last, we need to look for BC. So cutting, we can cut a segment through BC, member CF and EF. We already have EF, so we need to solve for CF. So here segment C-C. So skipping the drawing part, we would take the sum of forces at F equals 0, counterclockwise positive. 20 multiplied to 12, 6 plus 6 is 12, and we would have the slope of BC with respect to x multiplied to the moment arm of 6. So we need to input it. Equals 0. Answer shift solve should be, okay, what the hell happened? So there you have it, 72. BC equals negative 72. It means we are on the other direction. BC is 72.11. It should be in compression. Compression. So our limit for compression is 14 kips. Over ABC, area of BC, the cross-sectional area is also that is kips divided by 14 KSI. Area of BC, our cross-sectional area, is equals to 5.15. So writing 5.15 inches squared. So let us write the summarization. We need AB is inches squared. Area of member AG is 1.6167. Area of A is 1.43 inches squared. It should be in compression. Area of AG is tension and compression. Thank you, and let us move to our next problem. Hello, welcome to our problem number 10. Determine the mass of the heaviest uniform cylinder that can be supported in the position shown without exceeding a stress of 50 megapascal in cable BC. Neglect friction and the weight of bar AB. The cross-sectional area of BC is 100 millimeter squared. So I will skip the drawing part. So here we need to determine the height. This is a right triangle. So I'll calculator. Square root 10 squared minus 10 squared is the hypotenuse, so it should be minus the line, the one component of line. So first we need to, so we can observe that the cylinder is supported by the inclined rigid bar and by the wall. So we know that we need to draw the effect of the forces on the ball, because what we are looking for is the mass of the heaviest uniform. So we need to understand first its relationship. So since that is a vertical, it is easy, but we need to first to know the inclination of the rigid bar. Since we know that slope when perpendicular to each other is the negative slope of the perpendicular one, we would have, or slope 1 is equals to the negative slope of the other one. But now we only need to know the value, so we should use the absolute value. So simplifying, we would have 3/4. Next would be when answering problems like this, we need to isolate the bodies. So we need to isolate the cylinder to know the relationship of the support to the cylinder, the rigid bar in this example. So we can determine, so from the drawing we know that it is in equilibrium, right? It is one is going down and the other is going to the right, and this inclined support of the rigid bar, so it will cancel out each other. We have forces going down and right, and for our incline it is countering the two other forces, the vertical and the horizontal. So our slope is 3/4. The rise over run, our rise is 3, our slope 2 as a rise of 3, and the run of 4. So that is W. It's the force of gravity. It is the weight. Weight is mass times gravity. So as I was saying earlier, the support 1 or S1 and W is countered by the forces of the inclined support of S2 of the support 2, making the cylinder in equilibrium. So we need to determine sum of forces Y, because we need to understand or to calculate the effect of the rigid bar on the weight on the cylinder. So it is going down, so negative W. The support one can be neglected because it is on the horizontal. Now here we need to use the slope. So 3. So I did not calculate the slope. No, that is 5. So 3 with respect to the vertical. So it is 3/5 equals 0. Now we can write it. So writing it down, W is equals to 3/5 S2. But we need to know the support 2 and its effect on the rigid bar that we're gonna need later. So we write it on the other side. S2 is the reciprocal W, right? That is the value. Next is to understand on the rigid bar. You need to isolate the rigid bar so we can cut the cable, and we would know the load of the cable. We know that the load of the cable can be calculated based on the given. We have 50 megapascals and an area, the cross-sectional area, meaning we can already calculate the load, the tension, of course, because it is a cable. So in here, I will skip again. So we know that S2 is 5/3 multiplied to W. Now noticing the direction, since at the cylinder it is in compression, so on the rigid bar it must also be in compression, must be pushing it downwards. So here let's calculate. Let's write first the given. Let's calculate for the load of cable BC. So this is the restriction, which is 50 megapascals. So checking our units, that should be newtons per millimeter squared. So the load should be in newtons, which is good. So that is area BC. So let's write down for cable BC, the unit strength is equals to load of BC over area of the cross section of the cable. So we would have pascals, and this is BC, area which is 100 millimeters squared, newtons per millimeter. Our unit cancels out, so our value should be 5,000. I was double checking newtons. Since we have newtons, we can already take a moment at A, so we can cancel out the components AX and AY. So here we have a slope of this is 5, 6 divided by 2, so is 3, and 8 divided by 2 is 4. Sum of moments at A. equals 0, counterclockwise positive. What we would have is the moment arm, which is 8, the vertical component. So 5,000, it goes counterclockwise, 5,000 times 8. Now we have here, in here we have a inclined. It is a slope, it is not on the vertical or the horizontal. And we have a given inclined to 4. So let me draw so we can envision it. So this is the S2, which goes down. This is the length that is perpendicular to it, and this is the other edge. Now we know that it is 4. So S2 multiplied to 4 equals 0. So we need to substitute the value of S2, which is 5/3 minus, well, we can transpose it. It is 5/3 multiplied to 4. So W is equals to times 8. So alpha x as W, multiplied to R4, shift solve is 6,000, and should be in newtons. It should be in newtons. So we know that weight is equals to. So newtons is as mass times gravity. So for the unit, its unit should be, Newton is kilograms multiplied to the force of gravity, meters per second squared. So since weight is in Newton, it should also be the same. So 6,000 newtons is equals to the mass, which is in kilograms, our problem. So gravity is 9.81 meters per second squared, or 32.2 feet per second squared. But in here we are using the unit of meters. So here we need to use 9.81 meters per second squared. Unit of meters, so meters per second squared. Mass is equals to, so we are looking for the mass of the uniform cylinder that the cable BC can withhold with its limitation at 50 megapascals. So our answer is 611, that's 62 kilograms. So that is all. Thank you, and please for our next problem. Let's move to our next problem. So our next problem, the figure shows the landing gear of a light airplane. Determine the compressive stress in strut AB caused by the landing reaction R equals 40 kilonewton. Neglect the weights of the members. The strut is a hollow tube with 50 mm outer diameter and 40 mm inner diameter. I will skip the drawing part again. So here for this problem we need to cut the segment AB to expose the force on it. So let us draw the FBD diagram. I will skip again. So in the drawing, I still assumed a tension for us to try if the problem that will be given in the future is changed. Anyways, let's take a moment to see. 40 is going up. So 40, it goes clockwise. Times 600 plus 400 is 1000. And we have a load of AB going up in our drawing. 0. And that means AB is equals to negative 40 times 1000 all over 6,600. So we would have a negative. So it is definitely in compression. So we would have negative 66, that's 67. It should be in kilonewtons. 66, that's 67, which is in tension. So next that we need to do would be to determine the area of the hollow tube. Let me draw. Since this is a hollow tube, we would have a small diameter and a big diameter. It is also circular, so we have pi over 4 since our given is in diameter. Pi over 4 big diameter minus small diameter. We are of course in squared. This is area of hollow AB. Pi over 4, our given is 50 on the big and 40 on the small. So using our calculator, we will check pi over 4 squared minus small squared, 225 pi. 225 pi. What is next? Next should be, we can already calculate the, so using our limit, you can calculate the stress. The figure shows a light airplane. Determine the compressive stress. So we already have the compressive stress. Which should be in compression. So this should be in compression. This should be in kilonewton. So but we already found our answer earlier. I did not notice. Anyways, let's continue. Meter squared. Our stress should be 94.32 megapascals. That is our unit strength for our AB.